For many decades, one question has repeatedly come back to scientists studying Mars. Is it possible that life once existed there? At first glance, it seems impossible to imagine, because Mars today is a cold and dry world, constantly bombarded by radiation, and it has almost no environment that can support life. But as more missions are sent there, the evidence grows stronger that this planet had a different story in the past. Instead of directly searching for creatures or fossils, scientists are following something simpler, and that is water, because water is life. So if it can be proven that there really was water there in ancient times, or even if just traces of a river or lake are found, that would be a big step in the search for answers to one of the greatest mysteries of the universe. Despite this is also one of the longest scientific investigations in the history of space exploration. And in fact, the investigators here are not humans, but robots. They are rovers that are thousands of kilometers away from Earth, slowly crawling across the red desert of Mars while collecting pictures, rocks, and chemical data. But did they really find any traces of water there? And what other steps did the scientists take on Mars? And what were the results of what they did? And the most important question is, can humans really live there? That's what we're going to find out. But before we start, don't forget to like this video. This is a big deal for us content creators. Thank you very much, and now let's get started. In the early 2000s, NASA sent the Opportunity rover to Mars with a clear mission: to look for signs of ancient water. For many years, Opportunity crossed vast plains, sandy areas, and meteor craters. It traveled more than 30 kilometers, much farther than the engineers expected. As it continued its journey, the rover found different types of rocks and minerals that indicated some parts of Mars once experienced flowing water. But there was a problem. Even though there were signs of water, the evidence was still not enough to say that there was a long-standing lake or ocean there. It was possible that only temporary flooding occurred. It was possible that the melting of ice was only brief. So the scientists searched for stronger evidence. That's where a huge meteor crater known as Endeavour Crater became important. According to observations from orbit, clay minerals were identified around it. And for planetary scientists, clay is very important. These minerals don't just form easily. They are usually created when rocks interact with water for a long time. In other words, if there is clay, there is a high possibility that water remained there for a long period of time. As Opportunity got closer to Endeavour Crater, the view gradually changed. After many years of being surrounded by almost nothing but plains, they eventually saw hills and ancient rock formations appear. It was like opening a new chapter in the history of Mars. When the rover finally reached the edge of Endeavour, it arrived at a place called Spirit Point. It was called Spirit Point as a tribute to the rover Spirit, which also explored the other side of Mars. And from that location, Opportunity clearly saw the vastness of Endeavour Crater. And more importantly, it began to study some of the highest and oldest rocks it had discovered during its entire mission. This is where scientists began to strongly believe that ancient Mars was not like what we see today. Instead of a cold and dry desert, it was possible that it had areas with enough water to create a more complex environment. And as Opportunity analyzed more samples, it became clearer that the history of Mars was wetter, more active, and more mysterious than previously thought. But the truly surprising evidence doesn't end here. In the following years, more rovers would discover more signs that water once flowed on the surface of Mars for a very long time. Despite this, as Opportunity continued to explore the edge of Endeavour Crater, something further strengthened scientists' suspicions that ancient Mars was very different from the planet we see today. It wasn't a river, nor was it a lake, but rather traces of water that once flowed beneath the ground itself. In different parts of the area, the rover noticed that the rocks were not all the same. In some places, the ground was rougher. The rocks were sharper, and there were almost no traces of the unusual round minerals that had previously been seen in other parts of Mars. This showed that each region of the planet has a different geological history, and that's where some of the most important pieces of evidence began to emerge. One of the first discoveries was a large rock formed from the combination of older rock fragments after a powerful impact event in ancient times. As Opportunity analyzed the samples, scientists noticed elements that were not commonly seen in previous samples. This indicated that there may have been a process underground where water, heat, and minerals interacted over a long period of time. But the next discovery was even more remarkable. In one part of the rock, there was a thin white line that at first glance looked like an ordinary crack. Upon closer examination, it was discovered that this was actually a deposit of gypsum. On Earth, gypsum usually forms when water flows and leaves behind minerals as it slowly evaporates or moves within the cracks of rocks. For scientists, this is very important because it not only shows that there was once water on Mars, it also shows how water moved beneath the surface of the planet. It's like evidence left behind in an old underground plumbing system that stopped working a long time ago. The results became even more interesting. According to NASA studies, there are indications that the water that passed through that area was not as acidic as other water discovered on Mars. And if this interpretation is correct, it means that there were places on Mars in the past that may have been more favorable for simple forms of life. This is not yet proof that there was life there, but it is an important step in finding conditions that could support Utopia. As the months passed, another challenge emerged. Martian winter was approaching. Since Opportunity was solar-powered, it needed to find a place where it could still get enough sunlight to keep its systems alive. So the rover temporarily stopped at a rocky location where sunlight hit its solar panels more directly. While waiting for the cold season to end, the rover's time was not wasted. It continued to make observations and analyze the rocks surrounding it. And here, one of the biggest mysteries of Mars reappeared: the so-called blueberries. These aren't fruits, but small round mineral formations that were first discovered by Opportunity in another part of the planet. At first, scientists thought these were unique only to the landing site area. But when similar structures were found again in a new location, the situation changed. These ones are smaller. Their composition is different. They formed differently, as if another process was responsible for their creation. And until now, researchers are still studying exactly how they were formed. What's important is that many of the models scientists are studying are still related to the presence of water in ancient times. After many years of exploration, Opportunity made another discovery that further changed the way scientists look at Mars: a pale rock that didn't look like most of the others. In the samples collected before, after careful analysis, it turned out that this rock had undergone significant changes. Because of prolonged interaction with water, some minerals that are commonly associated with clay formation were found in higher amounts, and there were lower amounts of other elements typically present in fresh rock. For the mission team, this is one of the strongest pieces of evidence that Opportunity has found in its entire mission. After almost 9 years on the surface of Mars, the picture that is gradually forming is becoming clearer. Ancient Mars was not simply a dry desert. There were places where water once remained for a long time. There were underground fractures where mineral-rich water flowed, and there were environments that were possibly more suitable for life than scientists had thought in previous decades. But as more answers came, even more new questions emerged. If there were such places on Mars before, how extensive were they? Were there any ancient ones, lakes or deltas that would more clearly show the history of water on the planet? To answer that, NASA decided to send a new explorer to another part of Mars, a rover with more advanced equipment and a more ambitious mission. Its next destination is a place called Jezero Crater, a region believed to have once been home to an ancient lake billions of years ago. At this point in the investigation on Mars, the question is no longer whether there was water there in the past. Scientists are now trying to answer a much bigger question. If there really was water back then, was it enough to support life? To answer that, they need to find places that stayed wet for a long time and had a stable environment, not just places that were once flooded and then quickly dried up. One of the best candidates is the Jezero crater. According to NASA studies, even before the rover arrived, there were signs that this region was once connected to an ancient lake. From orbit, you can see shapes that resemble deltas, which are formed when a river flows into a larger body of water. On Earth, these kinds of places often hold sediments that serve as a natural archive of the past. So when the Perseverance rover arrived in 2021, one of its main goals was to study ancient rocks that may have preserved the history of water on Mars. But the mission was not that easy. Between the rover and its target rocks lay the vast sand dunes of Jezero. And on Mars, sand can be as dangerous as a cliff. Many scientists still remember what happened to the Spirit rover in 2009, when it got stuck in soft soil and was never able to move again. They don't want that to happen again. So before Perseverance moved forward, it first sent its small companion helicopter, Ingenuity. In the history of space exploration, this is the first vehicle to fly in the atmosphere of another planet. While Perseverance moves slowly on the ground, Ingenuity flies above the sands to look for a safer route. It's like an aerial scout leading an expedition team, and the information it collected helped the rover successfully reach the rocks that scientists have long wanted to study. And that's when another surprise began to emerge. At first, researchers expected that most of the rocks in the area were formed from sediments that accumulated underwater over a long period of time. But when Perseverance collected samples, the results were different. Many of the rocks originated from ancient volcanic activity. This means that before the lake in Jezero was formed, there was a time when the region's geology was active. There was heat, there was magma. There were processes that shaped the environment of the crater before it was filled with water. At first glance, this seems like bad news for the search for life. After all, it's hard to imagine organisms living in the midst of blazing magma. But as the samples are examined more closely, an important detail becomes clearer. These volcanic rocks also show traces of interaction with water. There are changes in their composition that usually occur when they are exposed to liquid for a long time. In other words, there is evidence that first there were volcanic processes and later water arrived. This sequence is very important because when water interacts with mineral-rich volcanic rocks, it creates some of the most suitable environments for the complex chemistry associated with life. On Earth, many microorganisms live in places where water and minerals from underground come together. This is not proof that the same thing happened on Mars, but it shows that some of the key ingredients needed for that to happen were once present. As Perseverance collects more samples, scientists' understanding of ancient Mars also expands. It's no longer just a story of rivers and small lakes. The possibility of larger bodies of water is gradually emerging, possibly lakes that lasted for a very long time, and perhaps, according to some studies, even ancient oceans. This is the next major chapter of the mystery, because if there were vast oceans on Mars before, that would be a big change in the search for ancient life. On Earth, the shorelines and shallow parts of the sea are some of the most active places when it comes to the chemistry of life. This is where different minerals accumulate. This is where water, heat, and different chemicals interact repeatedly. And this is also where some of the richest ecosystems on our planet can be found. So if there was a similar environment on Mars in the past, there might be places there with a higher possibility that simple microbial life existed. Over the past years, interest in this idea has grown even more because of new data from various Mars missions. This includes observations from the China's Tianwen-1 mission, which provided additional information about regions believed to have once been at the edge of the so-called ancient ocean. Although there is still no direct evidence of life, the discovered geological features continue to push scientists to seriously consider the possibility that Mars was once wetter and more alive than we have long believed. And if these suspicions are correct, the most important evidence might not be found on the surface of the planet. It might still be hidden beneath billions of years of dust, rock, and time, just waiting to be discovered by the next generation of explorers. If there's one place on Mars that seems almost destined, almost chosen for the search for traces of the so-called ancient ocean, it's Utopia Planitia. At first glance, it's just a vast and quiet plain in the northern part of Mars. But beneath its dust, it might be hiding one of the biggest clues about the planet's past. According to NASA, the Mars Reconnaissance Orbiter previously discovered a large deposit of ice beneath part of Utopia Planitia, almost as much water as in Lake Superior, if it were melted. So when the Chinese mission Tianwen-1 arrived on Mars in 2021, it didn't choose an ordinary landing site. This is a region long suspected to be connected to ancient water. The mission included the Zhurong rover, a solar-powered rover sent by China to study the soil, climate, subsurface, and the possibility that the area was once habitable. According to Reuters, when Tianwen-1 entered Mars's orbit on February 10, 2021, it became China's first independent interplanetary mission. And when Zhurong was successfully deployed on the surface of Mars, China became the second country after the United States to operate a rover on the red planet. But what is more important to science is not just the historical achievement, but what the rover found beneath the ground. It's not enough to just look at the surface of Mars. Over billions of years, many of the planet's ancient features have been buried by dust, sand, and volcanic material. So if there was once a shoreline, a beach, or an ancient ocean edge, it might not be visible on the surface anymore. This is where Zhurong's radar became important. It used ground-penetrating radar to send radio waves beneath the ground. When the signal hits different types of material, it bounces back to the rover and provides an image of the hidden layers underground. It's like an ultrasound for the planet. It doesn't directly see water, but it can detect the shape, arrangement, and layering of soil and rocks beneath the Martian surface. And that's where the unusual pattern appeared. According to studies published by the researchers, Zhurong detected buried layers that are tilted in the same direction. The appearance wasn't random, it wasn't scattered, it wasn't like ordinary sand just piled up by the wind. The pattern more closely resembles sediment layers formed in coastal environments on Earth, especially in parts of the beach that are repeatedly reached by waves and water. In other words, it's possible that there used to be a shoreline in that area. This doesn't mean that anyone has found direct fossils or life. But if the scientists' interpretation is correct, this means a lot. Because a beach or shoreline doesn't form instantly, it needs water that stays in one place. It needs sediment brought by rivers or flowing water. It requires the repeated movement of waves, wind, and changes in water level. This means that if a shoreline was really found under Utopia Planitia, what happened on Mars in the past might not have been just a simple flood. It might have had a longer-lasting, more stable, and more dynamic body of water, possibly an ancient sea or part of a larger ocean. On Earth, shorelines are very important for life. This is where water, land, minerals, heat, and energy meet. This is also where organic molecules accumulate. This is also where the chemical reactions needed to form more complex compounds can happen. That's why for astrobiologists, the possible ancient shoreline on Mars is not just a great geological discovery. It's a potential target in the search for ancient microbial life. But we still need to be careful. This is not yet final proof that there really was an ocean on Mars. There's still debate in the scientific community about how extensive the water was on the planet back then, and how long it lasted, and whether the features we see today were really formed by waves and tides. There are alternative explanations, such as dunes, lava flows, or other geological processes. But according to the researchers who analyzed the Zhurong data, the pattern matches coastal deposits more closely than other explanations, because the layers are tilted in one direction and have an arrangement similar to beach deposits on Earth. If this is true, the old picture of Mars becomes clearer. It's not just a planet that once had rivers. It's not just a planet that once had lakes in its craters. It's possible that it had shorelines, shallow seas, and areas that were battered by waves for a long time. And as we study it more deeply, the story becomes even more unusual. The Mars we see today is quiet, cold, and extremely dry. But beneath its red dust, there are buried layers like pages of an old book, and each layer carries a message. That once this planet may have had flowing water, there were shorelines. There were places that could have been home to the chemistry needed for life. And if there are traces of life left there, they might not be waiting on the surface. They could be underground, hidden between ancient rocks, in a place where the waves of a long-lost ocean once crashed. With all the evidence collected by different rovers, the story should be clear by now. There were ancient rivers. There were lakes. There are minerals that only form when water is present. And there are even possible ancient shorelines discovered beneath the Martian surface. But there's a problem. A very big problem. If there really was that much water on Mars before, why do scientists' calculations say it shouldn't be possible? This is where one of the biggest mysteries in planetary science comes in. It's called the faint young sun paradox. According to models of stellar evolution, around 3.5 billion years ago, the sun emitted less light and heat compared to today. And because Mars is farther from the sun than Earth, it's even harder to explain how water remained liquid on its surface. In simple terms, it seems there wasn't enough heat for lakes and oceans to exist. But if that's the case, why is there so much evidence suggesting that water really did exist? That's the puzzle researchers have been trying to solve for decades. There are a few main ideas that continue to be studied. The first possibility is that Mars used to have a thicker atmosphere. If ancient Mars had more greenhouse gases, the atmosphere might have trapped enough heat to keep water liquid for a long time. On Earth, this is also the principle behind why our planet stays warm enough to support life. But this theory also has its problems. According to many climate simulations, carbon dioxide alone is not enough to reach the level of warming needed to explain all the observed evidence of water. That's why some scientists are looking for other possible combinations of gases that could have helped warm Mars in the past. There's another explanation. It's possible that the warm climate wasn't continuous. Instead, Mars may have gone through a series of short warming periods. For example, when there are large volcanic eruptions or powerful asteroid impacts, the temperature could temporarily rise, melting the ice, causing water to flow, and forming some of the geological features we see today. But up to now, scientists are still not sure if those short-term warming events are enough to explain the extent of erosion and sediment deposits on the planet. There is also a third possibility that for much of its history, Mars was a frozen world, a planet dominated by snow and ice, and only occasionally did conditions become sufficient to cause melting. In this model, Mars was not permanently warm. Instead, there were only periods when water would flow again before freezing once more. At present, there is still no theory that can fully answer all the questions, and that is why every new sample and every new data from Mars continues to be studied. The discussion became even more interesting after some new analyses of rocks and clay deposits studied by the Perseverance rover were published. There are indications that some geological formations may have been formed in the presence of prolonged and repeated rainfall. If this is further confirmed by future studies, it could help in understanding how wet ancient Mars was. But in science, a single piece of evidence is not enough. More data, more samples, and more analysis are needed. That's why the rocks currently being collected by Perseverance are so important. Each sample tube is like a time capsule. It contains information about the climate, water, and geological history of Mars, things that can't be learned through pictures alone. For many years, NASA and its partner agencies have been planning to bring some of these samples back to Earth for more detailed laboratory analysis. But like many major space projects, this program has also faced various challenges with budget, costs, and schedule. That's why, until now, many important samples still remain on the surface of Mars, millions of kilometers away from specialized laboratories, and to be able to examine them in more detail. Meanwhile, the active operation of the Zhurong rover has also ended after it stopped communicating, following more than a year of data collection. Although it never woke up again, it has already made a significant contribution to our understanding of the ancient history of Mars. And as the collection of evidence from Opportunity, Perseverance, Zhurong, and other missions grows, a picture is gradually being formed. We are not looking at a planet that has always been a dry desert. Instead, we might be looking at the remnants of a world that once had rivers, lakes, and perhaps even vast seas. A world that changed drastically over millions of years. The biggest question now is no longer whether there was water on Mars, but what happened to it. Where did all that water go? Why did the environment that could support liquid water disappear? And most importantly, if life ever formed on the ancient shores, lakes, or underground of Mars, could there still be traces of it waiting to be discovered by the next generation of explorers? For now, we still don't have a definite answer. But with every new rover, every new sample, and every new mission, we get closer to the possibility of answering one of the biggest mysteries in the entire solar system.